In this video, we will study how AC voltages and currents are measured. So it is totally different from DC. We are all familiar with DC voltages and currents. Because of the smartphones, we always use the battery of the smartphone and the charger of the smartphone. There we will say that smartphone is having 3 volts battery and a 12 volts charger. And for automobiles, if it comes to automobiles, we will say 12 volts car battery. These numbers will directly tell us what is the voltage the terminals of the battery gives. And the current also, you can say the current capacity is 2 amperes, okay, of this battery, then it is 2 amperes. So it is all straightforward. There are no calculations involved. So let us represent graphically. This is 0. This x-axis is time, okay. Y-axis we will take voltage. So when you say 3 volts battery, it is 3 volts. When you say 12 volts battery, it is 12 volts. So 2 amperes current, then it is 2 amperes current if you are measuring current. Okay. So here it is straightforward. There are no calculations. So coming to AC measurements, in the house, if you say 220 volts AC supply, so here we are not talking much about frequency, it is 50 hertz, and the current also we will say sometimes 2 amperes current, so and so appliance will take. Okay, let us take 2 amperes current. Okay, how this is represented? So all of us know that in AC it is cyclic voltage or current, and it is 50 times 50 hertz means 50 times per second. So this is again time axis. So let me draw one full cycle. So like that it goes. So this is one full cycle from here to here is one full cycle. When we say 220 volts, so which part of it represents 220 volts? It is every every minute or every second it is keep varying, or seconds are too many. Every microseconds if you take, it is continuously varying. Okay, and if you take seconds also, second will come after some time. That time it need not be same. It can be different. So what is this 220 and 2 amperes means in AC? So these are all I already told, RMS values. Okay, that is RMS means root mean square value. That we will try to understand. Okay, in an AC, let us take voltage first. So here we can represent this point, maximum point, as VM, maximum voltage. If it is current, we will say maximum current. Okay, IM, M is for maximum. Okay, and for every cycle it varies. So if you want to take average value and then show it, calculate and tell this is the value of the AC voltage or current. If you take average, this is positive cycle, this is negative cycle. So if you add these two, it will give 0. So you cannot use average value here. So for that purpose, so what is done is, let us take here again time axis. So I will mark these points. Okay, I said RMS means root mean square value. So first what we will do is we will square this value. Okay. So if I square this, it will become double, but it will be positive only. So like this. Okay. These are negative values. If we square it, it will become positive value. Correct. Similarly, this also will become like this. This is mathematically or electronically also you can square it. Okay. So if I square also, the shape is same only. So what I will do, I will take mean. Squaring is over. I will take mean of this. Mean means, so every microsecond I will measure the voltage. Here. Okay. Here I will measure the voltage every microsecond for one full cycle. Okay. That will give you some total value. Now everything is positive. Now how many samples you have taken, you divide with that, the total value, and divide with that, you will get mean. It is from statistics. Let us take the mean value is something like this. It will be definitely lesser than this value, peak value. So it will give some mean value. So mean is over. So mean is, we are not telling mean value, we are square rooting that. This whatever value we got, total value, you square root it, it will be smaller than this. This is the root, square root of that. So this value, we will mention it as V, RMS value, capital letter. If it is current, it is I. Both are same. In AC, current or voltage, both are oscillating. Okay. So root also we have done. So this is how we calculate the RMS value. So RMS values, suppose if I want I, RMS value, I maximum value I will take. So maximum we will represent always with small letters, okay, by square root 2. Voltage also same. V RMS is equal to V maximum by square root 2. This is 0.707 IM. V is 0.707 VM. So suppose if RMS values are known, we can calculate the maximum values. That time from this IM is square root I, VM is square root into V RMS value. So this is equal to 1.4 I is equal to 1.414 V. Okay. So these are the equations involved here. So let us solve two examples. Here, for example 1, the peak voltage of an AC supply is 300 volts. So what is the RMS voltage? So peak voltage is given. So let me draw a diagram. So the peak voltage of an AC supply, this is 300 volts. Okay, what is RMS value? So VM is 300 volts. RMS V is just capital V, that is VM by square root 2. Okay. So that is nothing but 0.707 into VM, 0.707 into 300. So it is 212 volts. So the RMS is 212 volts. Similarly, we will see the second question. The RMS value of current in an AC circuit is 10 amperes. That is I is equal to 10 amperes. What is its peak value? That is Im. Im is 1.414 times I. So 1.414 into 10 is 14.14 amperes. Similarly, we will represent here. This is the current waveform. So RMS is 10 amperes. So when we calculate the peak value, it is 14.14 amperes. So you please remember this. Whenever you measure an AC voltage, it is not like DC voltage. So we are doing squaring, we are taking mean, and we are taking root. So that's why it is called root mean square value. So when we always say the AC voltage, we are always referring the RMS value, not the peak value. Peak values are higher than RMS values.